Confirm all your notes at the end of this term. Make sure you keep chapter 7. Oh, the last section. Oh, put some more safe for the rest of it. Okay. X-intercept. What's the x-intercept? The one that is your zeros of your functions. Your x-intercept are your zeros. What's the other name for it? So zeros, x-intercepts. What else do we call them? Roots. Okay, so roots of the function of zero. Okay, what is that? What you said it, Emily, where does it cross? Crosses the x-axis. Or in parabola, it can touch, right? Doesn't necessarily have to cross. Ooh, that's supposed to be an x. What's the y value at the x-intercept? And we know that we're looking for, just do a nice linear function. That's my x-axis. And we know at that point, y has a value of 0. Right? Easy peasy. So we did these in grade 10 with linear functions. We did them in grade 11 with our chapter 4 quadratics. Right? So we've done these a ton of times. So y-intercept has no new other fancy names. We know when we're looking for the y-intercept, that's where it's going to so that's this one right here. We know that the x value at that point is 0. So when we're solving for the y-intercept, x is equal to 0, and it's where the graph crosses the y-axis. Okay, so a piecewise function. This is where students in the past have said they didn't like this. Graphing, not the problem. Stating it as a piecewise function, that's a problem. Okay, I don't think it's a problem. I think we're all pretty smart. If you can do domain, you can do piecewise function. Okay, so it's a domain statement. You guys know what I mean by a domain statement? Like, it's x has to be between -3 and +2. Just like we write a domain, right? But we're going to write it specifically about 2 different things about this graph. First part is going to talk about the original. Original and speak at the same time. So we're going to break it into 2, and you're going to understand this a little bit better after we graph. So first is the original part of the graph. The second part is the absolute value part. Okay, so like it is an absolute value. Why there are 2 parts? I'll explain it as we graph. All right, so we're going to break it into 2, and it is a domain statement. So we're going to talk about it solely in relation to where we are on the x-axis. What happens between here and here? Kind of like a road map. All right, ready? Okay, so we know that this is an absolute graph because it has a field goal. Okay, so it's in absolute value brackets. Let's, for funsies, graph this. You guys remember how to graph a linear function? Yeah, it's easy. How I do it is I'm going to graph the y-intercept first. So where's my y-intercept? -3. Oh, some influence in there, so that's -5. All right, feel better about life. So -3. So 1, 2, 3. There's my y-intercept. My slope is a +2, so that means I go up to 1 to the right, up to 1 to the right, up to 1 to the right. I can also go down to 1 to the left, 1 to the left. Do my best to try to connect these in a straight line. You guys okay with that? Did you guys graph? Are you guys okay with the way I graphed it? Do you guys like doing a table of values better? I need words. I need feedback here, folks. No, you're, thank you. What? It was understandable? Okay, nobody's talking to me. I'm just talking at you guys. Fair enough. Okay, so that was grade 10, right? So everybody should be able to do this. And so I'm going to ask you to do linear functions in absolute value. I'm going to ask you to do quadratic functions. So I'm going to ask you to graph chapter 3, but as absolute functions. Okay? It's going to get more complicated. So this is grade 10, so I'm assuming you all can graph a line. If you don't know how to graph a line, then you need to come see me at some point or watch a video online. I think my grade 10 videos are up on our YouTube channel, so if you want to go back, there's probably more interesting ones up there that can do it a lot faster. Okay, so let's talk about the y and x intercepts of this graph. So what's the y-intercept? Y equals -3. What's my x-intercept? 1.5. Everybody know how I got that? I love it. If we said y would be equal to 0, right? It's just a coordinate on the graph, but it's a special one. It's where it crosses the x-axis. So I solved for both of those. I will tell you that your x-intercepts are the most important points, the MIPs. Okay, these are your most important points on absolute value graphs. Okay, super important. You need to know where your x-intercepts are. So what that also tells you when we do this on a parabola, you need to be able to either factor or use the quadratic formula. And you just did your reading for chapter 4, so you all should be brilliant. Okay. So what did we say about absolute values? What can they not be? Negative. Now, my x's can be negative because I can substitute a negative value in here. What can't be negative on the graph? It's your y values. All right, so that's fun. So what does that mean about this whole portion of the graph down here? We care, but it can't be down here, right? So if this were -3, and I take the absolute value of -3, it now goes to +3. So this one would flip up to +3. This one would flip up to a +1. This one would flip up to a +5. And this one would flip to a +7. This portion of the graph will flip too. But my x-intercept is like the turning point. Because I know none of this can exist in an absolute value graph. Now, my graph is this. It is a V, not a parabola. So that's why I was so particular about your parabola being that smooth curve and not a V, because a V graph indicates that you're an absolute value graph. These are, yes, yes they are, because the linear function is symmetrical. Yeah, it should be symmetrical, yeah. And then, that's inverse function, sorry. I'm off on a different time because you're giving me the reflection line equation. But yes, they should be exactly, because this is the same distance away as this is here. So it will be symmetrical both in parabolas and linear. Okay, so sketch the graph. Take the domain and range of the graph. Okay, so we did A, good job. We're over to B, good job. Now let's move on to C. What is the domain? And the thing is my orange graph is my y equals absolute value 2x minus 3. So I have two graphs on the same coordinate plane. So this is the detail oriented stuff. I put two graphs on, my green one being my linear function. So it has to be labeled. My orange one is my absolute value, so it has to be labeled. This question did not ask me to graph my linear function. It did not say to graph it. So when it's asked for the domain range, the graph it asked me to graph was the absolute. So that's the one I'm doing the domain and range of. Does that make sense to everybody? I graphed this to help me graph my absolute. This was a helper graph. Does that make sense to everybody? I use this to help. Okay, so domain and range is on my absolute. So what's my domain? Okay, positive infinity, negative infinity, positive infinity. Or you could have said x here. X is an element of all real numbers. I was trying to teach that to my grade 10 today. Didn't work out. I tried. Range for this one? Okay, so y's, right? Yeah. So we are square bracket 0 to positive infinity. Here's following the break. All right. Okay, so that's good. Now we're going to write it as a piecewise function. So this is a domain statement. So when I'm talking about domain, everything's in relation to the x. So what we're going to do first is the first part of our piecewise is I always like to do it in the same order because it makes more sense to me. It's okay if you don't do it in the same order, but I like to get into the habit of doing it in the same order. So I do the original. I'm going to say what part of the graph. When I talk about the original graph, it's that helper graph. It's the one without the absolute value. So what part of the domain is shared with that green graph? Where does it start? 1.5, because that's my x-intercept. Like I said, it's the most important point. So x-intercept, and where am I going? So positive infinity. Okay. So x has to be greater than or equal to 1.5. That makes sense to everybody? Because that's my original graph. That's the one without the absolute value brackets. Which was the one that we had to do something to? So where did we start? 1.5. We're going left. So that would mean x has to be less than 1.5. Hey, Miss Kelly, you didn't put the equal to sign there. So x, okay, so when y is 0, 0 is neither positive or negative, right? You guys would agree with me with that one? But if I have to pick a side for it to be on, I always pick that it's going to be positive. Does that make sense? Like 0 is more likely to be positive than it is to be negative, and negative 0, that's really weird. So we always put the x-intercept, usually with the original. Does that make sense to everybody? Everybody, no, that makes no sense, but I'll follow your rule anyway. Okay? Only one of these can have an equal sign. Okay? And it usually goes with the original graph. Okay? All right, that's it. That's the domain statement. Easy peasy. Are you guys okay with that? Nobody's crying yet. I think you're all slightly dead this morning. And it's Thursday, which is scary. Okay, so now we're going to be a little bit more complicated. Okay, I'm going to talk, I'm just going to go back here for a quick second. I'm going to ask you questions like, what part of the graph did you flip? And what I mean by that is, see how we took this and we flipped it. That's my language that I use to talk about applying the absolute value. So if I talk about what part of the graph did you flip, I may ask you that question. I'm talking about the part that couldn't be negative. Make sense? Okay, so determine the x and y intercepts. I got the first one. Okay. We're good. Okay. Maybe we should have done this lesson before you did your review. Okay, so now we're going to do x-intercepts. So we do it one of two ways: we factor, or we what? Or program a formula. I think I'm going to factor because it's faster. So all I have to do is I'm just going to, so this is my scrap paper somewhere. 0 equals negative x squared plus 2x. It stresses me out when the x squared is negative. So I'm just going to factor that negative 1 out. I don't know why it's not angry about this. So this is going to be negative 1, x minus 4, x plus 2. So x equals a positive 4, and x equals a negative 2 for my x-intercepts. You guys with me? Okay. Okay. What other piece of information do I need for my parabola? No slope and parabola. Wait till you get to calculus, there's a slope and parabolas, but we don't talk about it. So the elective course. I need my vertex. Okay, so again, this is my scrap piece of paper that I'm working on. So what are we going to do? Are we going to complete the square, or are we going to secret formula it? Oh, I love it. Complete the square. You guys want secret formula. Okay, let's complete the square, and then you crazy secret formula people can double check my work. Okay. Oh, this is nostalgic. Completing the square. What do we do? First step. Rebecca's like, I don't know. Formula. Okay, we got to group our x's, and we're going to common factor those. You guys remember that? Okay, and then we're going to do a side note. So we're going to do our side note. We're going to take our b value, divide it by 2, and square it. So that should be a plus 1. So if I add 1 inside, I subtract 1 inside, and I multiply it by the coefficient. So then I have y equals negative 1. Factor this, and this should be a perfect square trinomial. So my vertex is at a positive 1 and a positive 9. Which way is my graph open? Yeah. A little bit. Not happy about this, but we'll get through it. Okay, so I need to do some fancy numbering. Okay. All right. I hope that's enough. So I went up by 1s on my x-axis, and I went up by 2s on my y, just because I need some space to get to 9. Okay, so let's graph just this graph first. So y equals just the parabola. So we said my vertex was at 1 and 9. And we said it opened down. So I have intercepts at 4 and negative 2. And this one will be a nice smooth curve. I can get it to my points. So this one is my y equals negative x squared plus 2x plus 8. So this is my helper graph, right? You guys with me? Yes? Okay. So now, what do we know can't exist in an absolute value function? Any negative what? So those can exist in an absolute value graph. So what happens to them? It turns into a bouncy ball shape. The arms flip up. Okay? I like to call this the hump, and these the arms. Okay? So camels don't have arms. They do now. All right, our new fandangled camels have arms. And these arms are really negative. So you would agree that this part of the function stays put, right? You guys would agree with that because it's positive wise. And the arms flip up. It's a hump with two arms. Miss Scully using notation. So the arms flip up, so that's easy to see. Okay, so and I have two graphs on this, so I gotta label this one y equals, hey, is anybody going to get upset with me because I've forgotten to do something on both graphs? How come no one's called me in on it? I haven't labeled what? I haven't labeled 2 points, right? So somebody should be asking me point 5 as I go. Thanks. You missed it on the last question, so I guess do it this time. Okay, so 2 points labeled on every graph no matter what. Makes sense that I would label these two because I've already done them. Notice I didn't do a table of values for this, and notice I wasn't super specific on where these arms went. They just have to mirror these, so it should be a reflection in the x-axis. They should flip up. If I did something like this, if I do them like that I would call a half mark reduction and an incorrect shape of the graph. Because that's not how this the blue arm is. Does that make sense to everybody? So it should look close. It should be a reflection. All right, good. Okay, so we've done A, we've done B, and we C. Take the domain range of the absolute value graph only. So what's the domain? Okay, all the negatives and infinities, all the infinities of every kind, round brackets around both of those. The range. How come? Normally it's 9, you're absolutely right when we're dealing with a regular parabola, but these arms are going to continue forever and ever and ever. Okay, that's called the local maxima. That one here. This graph wouldn't have a maximum because it continues on forever and ever and ever. Imagine you look very confused. Are you okay? The x coordinate for the range. Because what's my lowest y value? It's 0. I can't go any lower than 0 in an absolute value graph. But these arms tell me I can go all the way to positive infinity. This isn't a coordinate pair. This is a statement of this. Okay. All right. So D, piecewise functions. Okay. So this is where life gets a little bit complicated. So you guys can handle this. This is perfect. Okay, so the original function was y equals negative x squared plus 2x plus 8. Okay, now what part of the graph, the hump or the arms, belong to the original? The hump, right? The hump is shared with the blue, right? So the hump is part of the original. So that's a specific domain, that's a very specific set. Where am I going to on the domain? Where's the lowest part of my hump? Okay, but we're doing a domain statement. -2. Where's the furthest right? 4. Okay. So here's the thing, we never rate it. We never rate it in the set notation. And this is where we thought of, because we need to rate this one in the set notation. So lower limit on the left, upper limit on the right, put your X in between, and all your things will point to the left. Put some fancy brackets around that. I really like using fancy brackets. Oh, no. Do you know? Yeah, you know. Cool. Those are your x-intercepts, right? Yeah. What did I say were the most important points? X-intercepts. Because in your piecewise function, it's all based on your x, it's based on a domain statement, and it's all based around those x-intercepts. Okay, so now we're going to do our absolute value. Okay, so here's the problem. How many arms do we got? We have 2. Our calculus specialist is 1 month with 2 arms and nothing else, okay? So 2 arms in this. So we're going to make 2 domain statements. So let's talk about our left arm first. What's the lower limit on the left arm? No. Oh, domain statement only. Domain only. How far left does that left arm go? Infinity. How far right does that left arm go? -2. Okay, so we've got all the way to infinity to -2. You guys with me? So we're going to say x has to be less than -2. That's the left arm. Feel free to label them if it helps you understand what we're doing. You don't need to, but it does help sometimes. Okay, so now we're going to talk about our right arm. Where does our right arm, what's the furthest left that our right arm starts? 4. And how far right does it go? Infinity. So x has to be greater than 4. Okay, now we need these things to happen at the same time, because they're all happening on our graph as we speak. So in math, we're going to say this happens in unison, happens together. Unison needs to come together to connect. But in math, we are efficient, so we have a U without the little stick on it. I don't know why. So this happens in unison with that. I forgot who. Yeah, kind of. So U without a stick. An uppercase U without a stick. Really? Are you sure? Yeah. I don't think you're right. In cursive? Cursive. Oh, in cursive. Okay. What's the name of the Y? Okay. All right. Now. Okay. So I just want to point out that if our hump had flipped, so in a parabola, you've got 3 parts. You've got the hump, and then you've got the 2 arms. The arms are always going to be a set. You're never going to have a hump and an arm. You're always going to have 2 arms together. Does that make sense to everybody? And your arms will do the same thing. Because if I had a graph that did this, what flips? The hump flips up. So the arms would belong to the original, and the hump would belong to the absolute. Okay. Sure. You can tell them. Why don't we do this graph without opening down? Because then we have everything that we need. Okay. You guys ready for this? Okay, so y equals x squared minus 2x minus 8. Back off. Because this is going to give me x-intercepts of x equals positive 4, negative 2, y-intercept of negative 8, and where's my vertex on this one? Is it still, I'm just wondering because I switched the numbers. So this would be x equals 2 over 2, so x equals 1. If I substitute 1 in here, it'd be a negative 9. Okay, is everybody with me so far? We're going to do this one. This is an extra example. I'm just doing a rough graph of it. So I just kept this because it was similar. So my vertex, or sorry, my x-intercepts would be the exact same. Those are the most important points. My vertex is a positive 1, negative 9. So rough graph, positive 1, negative 9. So I'm here, here, here. I've got that going on. Okay, now we do the domain and range and everything like that. We're just going to do the absolute function, right? So that's the original graph. I guess we should absolute value this. So that one's the original. And then what's going to flip? The hump. So this 1, negative 9 is going to flip to 1, positive 9. So now my graph is the W. The hump's what flipped this time. So we're going to do a piecewise function for the hump. Okay. So we start with the original. So y equals x squared minus 2x minus 8. And that one, what stayed the same between us? The arm stayed the same. You guys think of the second problem that down in practical property? So this one, the arm stayed the same. So we would have x has to be less than negative 2, and x has to be greater than positive 4 in unison, fancy brackets. And then for the absolute one, we flipped the hump. And I'm pretty sure that flipping the hump is not a technical math term. Just in case you use it in public, people are going to question it. So again, we're writing it as set notation. So lower limit on the left, upper limit on the right. Put your x in between them. Ooh, these should now have the equal signs attached to them because the zeros go with the original function. So these ones won't. So the hump is always one statement, and the arms will always be two statements because you have two arms, one hump. How do you guys feel about that? Everything's okay until the piecewise function? Yeah, sorry, that's an equal sign because we've always put our equal sign with the original. We good? Like tears? Represent the arms, yeah, always, yeah. Okay, so our quiz on Monday. What? No, but I taught you both lessons, so I'm going to put 7-1 and 7-3 on your quiz. Mr. McCullough can totally help you.